Hey guys, this is Lucas from Better Coding Academy, and in this video I want to give you an introduction to recursion and learning how to think in the recursive mindset. So I was actually having a look through YouTube and through some online sources for recursive tutorials, and I found that a lot of them, well basically all of the ones I had a look at didn't really go in much more detail than a simple factorial function. And I think that actually doesn't really do justice to the topic of recursion and of thinking in a recursive mindset. I'm a big believer in actually thinking of problems recursively and actually seeing the value in approaching a problem in that particular way. So what we're going to do today is we're going to actually look at a reasonably difficult problem, and I'm going to show you the way that I would actually break it down and the way that I would construct it using a recursive function design. So this is a question we have here. Alice and Bob are playing a game using a bunch of coins. The players pick several coins out of the bunch in turn. Each time a player is allowed to pick 1, 2, or 4 coins, and the player that gets the last coin is the winner. Given the number of coins and the names of the two players, you are required to write a program to calculate all the possible ways that the game can play out. So that's what we're going to do here. Essentially, we're going to have two players and we're going to calculate basically the different ways they can take the coins from the pile. So we're going to go into VS Code here. I've just got an empty directory. I'm going to create a file called recursion.js for this one here. Now let's first look at the syntax that would probably make the most sense for this function. Now sometimes you may be given this, sometimes you might have to figure it out. In my case here, I'm going to figure it out. So it's probably going to look something like a coin game function for the actual recursion. So like that's the basic syntax for the function there. And then we might do something like console.log coin game, and it might have say 2 parameters. The first one here might be num coins. So we pass in an argument value of 5, say there are 5 coins, and then we might have a list of players. So we might do Alice and Bob like that. So we have the 2 players and we have the number of coins. Now before we continue, let's first talk about the actual requirements of this project in a bit more detail. And I want you to actually think this through with me together. So if we actually consider what's going on here, we need to have a recursive function that basically says first Alice takes 1 coin, then Bob takes 1 coin, then Alice takes 1 coin, then Bob takes 1 coin, and finally Alice takes the last coin. So this is the kind of information that our recursive function needs to generate. So the first thing you might ask here is, Lucas, how do we actually switch between Alice and Bob? Now this is a question I actually get asked quite a lot, obviously not that exact question, but that nature of question, which is how do I preserve state between function calls when I'm doing recursion? So for example, how do I let my function know that the current player is Alice, and then how do I switch that into Bob, and then back into Alice and back to Bob, and so on and so forth? How do I actually do that within my code? Well, there actually is no single magic bullet solution to your question, and the way that you would do it is basically dependent upon each project and each situation individually. So for example, this one here, we have 2 players, Alice and Bob. So what we can actually do is, because we also need to specify them as part of the game, we can actually put them inside an array, and we can have a rule, which is that the first player inside of that array is always the current player. So then when we call the function recursively inside of coin game, we simply swap those 2 around, and then what that would allow us to do is change the current player. So there are always ways of doing it in a very nice and neat fashion, but you generally don't want to do stuff like have, for example, a current player here at the end. That would be kind of bad because it doesn't really make sense at the top level. So it might make sense for every function call underneath, but you have to think about what the top level actually does, and you generally don't want to add on syntax that doesn't make sense at the top level. And even worse than that is having something like let current player as like some sort of variable outside of your function. That's definitely a big no-no. There are a couple reasons here. Number one, you're creating a global variable and basing your function value off of that, which is always an issue. Second issue is that now your coin game can't really do the proper calculations for itself, so there's really no point in having that either. So this is probably what I do. And now let's actually think about what the output of this function is going to be. So in our case here, we're going to have an output that looks something like this. So firstly, it's an array. It's going to be an array of possibilities, and each array inside of here is going to be the possibility set. So for example, inside of here, we also do another array, and this array is going to be firstly the number of coins taken by that particular player, and then the name of the player. For example, 1 Alice, and then after that will be 1 Bob, for example, and then Alice takes another coin, then Bob takes another coin, and finally Alice takes the final coin, making her the winner. So that would be one example of a possibility set. And then you might have something else here where instead Bob takes 2 coins here, and then hence Bob is the winner. So then this would say, for example, go on and you have each possibility there. So this is essentially the result that we're trying to build, and we're trying to build this one out recursively. Now you might be wondering, how do we do that? And it can definitely seem daunting from the beginning. I completely understand. But what I would suggest here is, instead of looking at this, let's first look at the most simple example. Firstly, let's look at the question and see if we can identify what the most simple example is. And what I mean by that is an example where your function doesn't actually have to call itself in order to get it working, is where you have a value set you're passing into CoinGame such that it actually doesn't need to run itself. It can already just produce the value from the function. So that's like, it could call it the root of the recursion. So in this case here, the actual root would be one coin, because there's only one possibility, which is picking that one particular coin, and then hence there is no reason to loop through it any further. So therefore, what we're going to do here is we're going to first set up the code to write for that particular possibility. So we're going to write that out here. So we're going to just comment out this line here for now, change this one to CoinGame1, and let's first look at the output that we actually want to receive. So it's going to be an array of possibilities, and we're going to have one possibility in here, and that one is that Alice takes the first coin. So with that in mind, let's go up here into CoinGame again, and let's write in, say, numCoins, and then say players list here. And then we can do a couple of simple housekeeping things. First one is getting the name of the current player. So const current player is equal to player 0. So basically this one's going to be Alice, for example, here. And now the other thing we need to do is we need to define the numbers 1, 2, and 4 somewhere inside of our code. So let's go up here and let's do a const, for example, num can pick. This is probably what I do here. So the reason we want to do something like this is we don't want to actually hard code these numbers inside of our function without properly explaining what they actually do. So by having num can pick here, it really allows us to identify exactly what we're trying to do here. So having that there is really beneficial. So now let's go into our CoinGame and let's actually identify why this one should return this. Well, what we're going to do here is, firstly, let's have an array for our possibilities. So this is going to be our top level array, this one here, that whole thing. And obviously it starts off as empty. And then what we're going to do is we're going to do num can pick dot for each. For each here, and then let's just do, say, num coins to pick. So this is the number of coins that we would pick. And then what we do here is we can just say, for example, if num coins triple equals num coins to pick, then what this would do is this would allow us to do possibilities dot push, and we'd be able to push in a full possibility like this. So do that, and then just do square brackets for this section here, and we'd have to do another set of square brackets, and then num coins, and then the current player name. So we have basically this whole thing there. We just push it straight in. We don't worry about recursion yet, and then down here we do return possibilities like that. So now, once you do that, let's actually run this code here. So I've got my recursion over here. Let's do a node recursion.js. And you see we get triple square brackets, 1 Alice like that. Obviously the formatting is a little bit different, but that's not an issue. Our code is working correctly so far. Now, obviously, if we were to try and do, like, say, a 5, this would no longer work. We'd have some issues there. And obviously the reason for that is because we don't actually have recursion set up. So now this is the base situation, is we have the code set up for 1. Now let's think about what happens when it is greater than 1. For example, if we have 2 coins, what actually is going on here? Well, what's going on is we first take num can pick dot for each num coins to pick. So we have, firstly, is 1 coin. So when Alice picks 1 coin, what are we left with for Bob to pick? Well, Bob can only pick 1 coin. But see, this is where the recursive mindset really comes in, because you need to understand that for the coin game here, which we're going to call C, so I'm just going to do a bit of pseudocoding here, is that when we do, say, for example, C2, and we'll just call these ones A and B for simplicity. So Alice and Bob, when we have 2 coins, if Alice picks 1 coin, then the subset becomes, I'm just going to write here, if Alice picks 1 coin, then the subset becomes C1BA. So then basically Bob is the player who then picks. And then when Bob gets C1BA, Bob can only pick 1 coin. So the way it works is when you have C2AB, it actually depends upon the value of C1BA. So what I mean by this is obviously running coin game with only 1 coin left. So you can imagine that, like, every time someone plays this coin game that we're talking about, whenever someone takes a number of coins away and like into their pile or whatever, then the amount of coins that we're left with and the set of players is in itself another game. It's a little bit of a confusing concept, but the idea is that when you take away a number of coins, you're actually left with something which is in itself a new game. Now, obviously, it's a continuation of the original game, but you can think of it as a different game. And the benefit of that is that you can actually run this whole function on that sub game, so to speak. So in this case here, what we're doing is we've got num coins triple equals num coins to pick, and we have possibilities here. But what we can actually consider doing is we can consider doing coin game and say num coins minus num coins to pick. So this is basically assuming, so current player has taken away num coins to pick coins. So that's how many coins they've actually taken away. So this is the number of coins we have remaining. And what we're going to do here is, if you remember what I said before, we have Alice and Bob, which means that Alice is the current player. But in order to put Bob first, we just need to swap that around. So the best way to do that is to just do players.reverse. The problem with reverse is that reverse doesn't create a new array. So I think reverse array, it actually changes the current array. So yeah, it does it in place. So what we can actually do is triple dot players dot reverse like that, which will create a new players array for us, so we don't want to mutate or anything like that. And this is essentially part of the code that we also need to run. Now, the problem with just running it like this is that we're not actually using this value, because this returns some sort of value. And if we do it correctly, it should return a value which is useful to us, but we're not doing anything with that here. That's the first issue. And the second issue is that this actually goes on into infinity, right? Because num coins, say for example, now is 1, and then 1 minus, say 1, is going to be 0, and then it runs again, and then it does 0 minus 1 is minus 1, minus 2, minus 3, and it goes on into infinity. So this is the other thing with recursion that you have to understand, is that we also need to have a stop condition. So a stop condition is basically a point in which your recursive function no longer runs any further. So for example here, when we do C1BA, there is no further condition here that needs to be run. Nothing else goes here. So there is no further game inside of C1BA. Like once you have 1 coin there, someone takes that coin, the game ends, right? You can't play the game with 0 coins. So basically you have to have a point where the game itself finishes and it no longer runs. So in our case here, the best way to do that is just leaving this line here for a second, is we're actually going to go up here, and if num coins is less than 0, so if we don't have any, or less than or equal to 0 is probably best, then we're going to just return an empty array, which basically means we have no more coins, and as such we can't really play the game any further. So we're going to do that there. And now let's grab this section here, which we're going to call const inner possibilities. So this is, for example, the possibility of C1BA, where the outer one is C2AB. So now for C1BA, this one will return us something like this, except instead of Alice, it's going to be Bob. So basically, this line here on line 4 is going to return us this. Well, at least it should return us this. But then how do we turn this into the output for C2AB? Well, you have to understand that in order to turn this into that output there, we simply need to add back in the fact that Alice chose 1 coin. So when you do that, then you have the full possibility, well, one of the full possibilities for C2AB, because you got to understand that the reason we run C1BA is because the assumption is that if Alice has picked 1 coin. So therefore we have to add that back into what this function returns. So we add in 1 Alice there. But in addition to this, we also have another possibility, which is square brackets, and then Alice simply picks 2 coins. And then when Alice picks 2 coins, there's nothing else that we need to run. So if Alice picks 2 coins, nothing, right? Because once Alice picks 2 coins, we have 0 coins left. There's no sub game, so we don't run the function again. If Alice picks 4 coins, obviously that doesn't do anything, so we don't really need to consider that. What we're going to do here is we've got num coins to pick, and what we're going to do is look at lines 18 to 20. So 18 to 20 actually allows us to get this set up, because if, for example, num coins is say 2, and the num coins to pick is 2, then it will push that into our possibilities. So we're actually going to move this above line 17, so put that here, and then essentially want to do an else if here, if num coins is greater than num coins to pick. So for example, if there are 5 coins and then you pick 2, then it would allow us to have further possibilities, because we have 3 coins remaining. We can use that and continue to recurse. So then we have inner possibilities here. And for this one here, we're going to push into possibilities, but we're going to add in this part to the front. So the way we do that is we do inner possibilities dot for each. So when I'm doing something like this, I find it really helpful to think about an existing situation and like visualize it like this. So for example, let's just go back to our previous example here, let's just say we have say 2 Alice Bob, or actually maybe use 3, and let's just say that we've already decided that Alice has taken 1 coin. Then once Alice has taken 1 coin, we're basically doing, if you think about it, we're basically doing with 2, but then with Bob and Alice. So this is a subset of this game here. And then for something like this, we would do either Bob Alice like this, or just Bob. So then this would have this particular output. But then when you take this and put it inside this game here, we have to add in the fact that Alice chose 1 coin. So we have to do 1 Alice here, and we'd have to do 1 Alice here to add that in. And these are now 2 separate possibilities. So we have to add both of those in. So in order to do that, we've got now our inner possibility, which is this array here without Alice, and we're going to prepend Alice to the beginning of that. So the way we do that is possibilities.push, and we put our square brackets, and then we spread the inner possibility. So now we have Bob and Alice in there like that. And then before Bob and Alice, we need to put in square brackets, num coins, which is the number of coins Alice has taken. Oh, actually, num coins to pick. Sorry, it should be num coins to pick there. And then comma, current player like that. So we put in num coins to pick, current player. Remember, this one is 1 and Alice for this particular situation. So basically, we assume that we pick 1 coin for Alice, and then now we're running coin game 2 with Bob and Alice, which will give us this array, and we add in Alice to the beginning there. So we add this one here in here, and we also add it there. So we add those in and we push those possibilities. Now, one of the downsides to recursive function development is you really have to be able to think through your code very clearly. It's very hard to do console logs, obviously, because you can't really find the output of coin game before you actually write it. So when you do recursion, if it doesn't work, it's really sometimes seems very difficult to debug. But on the other hand, my solution to that is I think it's really good to actually test your ability to visualize what the computer is thinking. So when you write code, you actually have to consider yourself as a computer and run through the code. So if I'm running coin game 3, 3 goes into here, Alice Bob goes into here, Alice goes into here, for example, and then it runs this, and then num coins to pick becomes 1. And if it's 1, then what happens here, what happens there? And you actually learn to run through and go through the computer syntax, which really helps you as a programmer. So anyways, we have this here. Let me see if it works. I'd be surprised if it did. It does seem to be working though, which is surprising. So you'll notice here, we always start with Alice picking first, which makes sense. And then we have Bob picking, and then we have Alice picking at the very end here. But in these 2 cases here, Bob has 1. So now let's have a look down here for coin game 5. So let's just see if this one does the output that we had here originally. So let's comment this one out and let's try the bigger one. Alice, Bob, Alice, Bob, Alice, and so on and so forth. It gives you all of the possibilities there. And we just wrote a recursive function. Now, just to kind of recap and go through this again, it might seem a little bit confusing. If it is confusing to you, my suggestion would just be to maybe watch this video another time. It might start to make a little bit more sense. So to recap on a couple ideas with recursion is it's important to think in a recursive mindset. Now, the best way to think in a recursive mindset is to think of each activity as having sub-activities inside of it. For example, when you climb a staircase, after you take the first step, the remaining, say, 30 steps is another staircase inside of the original staircase. So if your first step was 2 steps, and then you have 29 steps left, say 31 steps in total, you took 2 steps, you have 29 left, then that 29 is itself another staircase. And it's the same as if you had a 29-step staircase to take in the first place. For this one here, with the coin game, is if you have, say, 10 coins, and then you take 4 coins away, then you only have 6 coins left. But then that 6 coin game is itself the same as if you started with 6 coins to begin with. Obviously, the only difference is that the players constantly swap, so we have to make sure we swap the players here. But other than that, it's the exact same game with 6 coins. So that means that you can actually call itself continuously. Now, the other thing with recursion to keep in mind is the stop condition. So the stop condition is what we're defining here. This one is part of the stop condition, and we also implicitly define it here, where we only continue if the num coins is either equal to or greater than one of the possibilities for picking. So we actually have that defined inside of here, just to make sure our function doesn't run forever. So those are some things to keep in mind when doing recursion. Now, I hope that this video has been helpful to you. I think that just leaving recursion as simply factorials is not doing it justice. I think recursion is incredibly interesting. I think it's a wonderful topic, and I think that once you understand it properly, it will really help you become a better developer. I hope you enjoyed the video. This has been Lucas from Better Coding Academy, and see you guys later.